first problem introduced by the old Big Bang Theory was called the horizon problem.
Which is basically the problem of trying to understand how the universe got to be so uniform. Why does the universe look the same over there as it does if you look that way?
And why was this the problem? Well, think of a cup of tea. If you pour milk into your tea, it'll take some time for the molecules to interact and eventually come to about the same temperature. But it won't happen instantly. The same is true on a larger scale. The fastest any two objects can interact is as soon as light has had time to travel between them. Well, according to conventional Big Bang Theory, light hasn't had time to travel from one side of the observable universe to the other. So why should they be at the same temperature?
So inflation gets around that in really a very simple way. Is that if we trace back the universe that we're looking at now to what it looked like before inflation, it was vastly smaller than anybody would have thought without the inflationary theory.
Vastly smaller is not an exaggeration. Before inflation, everything in our observable universe fit in a volume a billionth the size of a proton. Then the universe went through two expansions, inflation and after. Both expanded space by a factor of 10 to the 28, but the second expansion took 13.8 billion years. That first expansion, inflation, took 10 to the minus 38 seconds. It's just an unfathomable rate.
And it was during the time before inflation, when the universe was incredibly tiny, that there was plenty of time for every piece of the universe to communicate with every other piece, and plenty of time for it to come to essentially a uniform density of energy and uniform temperature.